So we are going to continue our thing. In the last class, we tried to see how we could write these statements, logical statements, and their relations, and sort of truth table constructed out of that. So in two-valued logic, the thing is that it was somewhat, in a sense, not that general. There were limited permutations and combinations. We could arrive at truth and false statements. While in case of three-valued logic, we also included intermediate as a quantity, as one of the values. So in that sense, there were a whole lot of possibilities which we could just arrive at, or which we could just construct or work out in that sense. But provided we also had the relations of negation, for example, complete. So in the sense that when we were constructing those alternate combinations vis-a-vis these three, truth, false, and indeterminate, we also took the validity of statements in stricter form, in weaker form, or in somewhat intermediate sensibility. So we could have negation, we could have strict negation, we could have cyclic negations, and we could have, for example, so in that context, we also had tautologies. Tautologies may be statements which are agreed upon, which may be arrived by diverse combinations, but those are sort of truth statements. But once we took into consideration the synthetic part of the statements, which were basically constructed, in the synthetic part of the statement, one part was true, the other part of it could be true or could be false. So you could construct different synthetic statements. A fully synthetic statement or a semi-synthetic synthetic statement, or a fully synthetic statement could have one statement true but other in the categorical way, whether it was true or false, the same in the sense. So the point here is how could rehabilitate quantum mechanical reasoning vis-a-vis this three-valued logic. Not, you can say rehabilitate, or the better word is that how it could better accommodate the language of quantum mechanics. There are three-valued logic, how the diversity in it, how it can incorporate or include how we can express it, the linguistic, what I should say, linguistic that in its case is how they can be incorporated, which are intrinsic once we go into quantum mechanical statement. So we are going to again do that exercise in that sense, how we could define these identities in some what I should say. We'll do the same exercise a bit more, and then at the end see how we can at least see things in that context. So you can say rule of identity which holds is basically rule of identity, which is, for example, A. So A, this means what? A, this means what? It means A, this means what? It's standard equivalence. So also I also said previously, also one is standard equivalence. The another is alternate equivalence. So in the same sense, you can have Synthetic statements can sometimes the synthetic statement may be having a truth statement and a statement which may be intermediate. So the sort of combination it might generate is we might reach at certain unassertable unassertable or unverifiable statements. In the same way, you can have equivalences, you can have standard equivalences, or you can have alternative equivalences. So standard equivalences may be more stricter statement as compared to alternative equivalence. So alternative equivalence doesn't necessarily mean standard equivalence. So if A is B and B goes to A, it doesn't mean that A always will, B should always go to some, the thing is there. So the same way, rule of identity says that this is this, and rule of double negation says that A, you can have this is standard equivalence. So negation of A, you will come back. So double negation. So you will have a negation of A. So true, false. Again, it will come back to where it started. So this is under rules of for cyclical negation, or it's also called rule of triple negation. You can you will have a standard equivalence. A will come to A after you have so I have done it like this way. You can see it. So thrice negation. So you come back to here. That's a cyclical sense. For complete negation, the rule of double negation holds such that A is basically 1, 2, 3. For complete negation, this is this thing. And it should be noted from the formula that standard equivalence of A cannot be deduced from this. So standard equivalence of A cannot be deduced from this. So you can have negation and it will come back. So I cannot deduce this from that. So from this we can say rule of double negation, does not hold directly. It doesn't hold directly. Yes. So between what I should say between negation, between cyclical and complete negation. Between cycle and complete negation, the following relation should hold. The relation is between cyclical negation and complete negation, following relation will hold. So this means that this is complete negation. This is cyclic negation. So this A implies this, but you can get it. So it's A double negation. It will come A back. So this is here. This is it. It's A of negative. So this comes out with this. Right. Because cyclical negations, you have three, one, twice, and thrice will come back. So, but you have twice this, it will come back, but then this is cyclical negation. This is the implication. A implies minus A is synthetic. So this means it's true statement, it's not a true statement, it's contained in a given statement. And for that is it's a synthetic statement. It contains true statement as well as false statement. So for a cyclical negation, A implies it's double of A. You'll get A back. A implies A. So first is negation and then again it will come back. If A implies negation of A, it implies this. So from this we can say A implies A negation. So this formula implies that complete negation. And at the same time, it reveals the reason why we introduced such a negation. So, but this entire thing says that if it doesn't enable us to infer truth, value of A if we know this negation of A is true. So from this, if a statement, for example, a statement is true, if you know the false of that true statement is true, but does it mean that the true statement is true? You can say it that way. So we cannot infer from this. So such an possible operation is impossible because truth tables would have to coordinate values of truth and this A negation of A. Sometimes value of I and A, sometimes F and A. So in two valued logic we could say it, but in three valued logic when we introduce truth and not a falsehood of A, so it has to go through, it has to be conjuncted with intermediate statement and false statement. So intermediate, once you intermediate and false statement, if you remember what we arrived at it in the table, intermediate and false, we arrived at conjunction intermediate, false, intermediate, true, intermediate. In case of equivalence, we arrived at intermediate only. So we cannot you arrive at intermediate statement in that sense. So you cannot infer the truth value of it because it will lead to an open-ended thing. We'll arrive at if we operate it, we'll arrive at intermediate statement. In the same sense, you can have rules of contradiction, which can be written as rules of contradiction. Which A of A bar, A of A, A of A. So you can have these rules of contradiction. Now you can also have, for example, the De Morgan's rule. How can see these in presence of these statements? For example, De Morgan's rule, A of, so you have negation of A is basically equivalent to negation of A minus negation of B. Or negation of A is equal to minus negation of A minus of B. In the same way, distributive rule is A of B implies C. Distribution is A of B and A of C in that language. Or A implies B dot C is A of B into A of C. The rule of contraposition. For example, A implies B is B minus B implies A. You have shifted minus sign from A to B. Or A bar negation of A is B means this implies B of A is A. So you have changed the contraposition means you change the position A to B, A bar to B, and DB goes to B bar. So then only this A bar goes to A. Or A implies B is equivalent to minus B implies minus A. Minus B implies minus. So with the change of signs, this equivalence can hold. In the same way, you can also have double negation, standard implication, and combination, and standard equivalence. In the sense that A of B implies A implies B, B implies A. There's another very interesting thing you can see. You can see it like this. The interesting thing is that, for example, A equivalent to B means what I was saying. One is standard equivalence, the other is the alternative equivalence. Statement may so you can see the stronger form of equivalence or the weaker form of equivalence means A goes to B and B goes to A, or it's here, or A goes to minus A goes to B, or minus B goes to A. So this is a double implication. So double implication doesn't have the character of equivalence. So since it goes from B, then middle, then to the log, then comes back in this. Because it's dispensable, because it follows from B to A by the value of contraposition. You also changed A to minus A, B to minus B. That's it. And by arrived at by alternate route. So it means So if A is true, B is true. But it doesn't mean, say, what if A goes to B and B goes to minus A goes to B, and if A goes to negation of A, B goes to negation of B. So if these two statements, so it doesn't go to the truth value of those intermediate things. It states nothing, states nothing about what happens when A and B have other truth value apart from A and B. So now the other point is that we can say that we can say is a dissolution by implication, means A goes to B, means this is equivalence, this is symmetrical negation, this is negation, this is negation. So you just see whether this statement is right or not. And other statements which can hold in the same sense is that reductive, so A implies A bar implies A bar, or A implies negation of A implies negation of A. So these are all tautologies. Sometimes A and negation of A means true and false statement, they are contained in one statement. That's a sort of, you can say it, true false statements. Or you can say they come under the rubric of plain synthetic statements. Not the other is semi-synthetic statements, the other are the more contrived synthetic statements where we take intermediate, undecidable. Intermediate is in conjunction with truth, or one part of the statement is true, the other synthetic statement, but the other part of the statement may be true or false. Then it's plain synthetic statement, or it may be intermediate. So if it's intermediate, the statement which comes out of these two combinations may be more. It's not. It cannot be. It can be unanswerable, or it can be undecidable. Unassertable is the pronoun. You cannot. You cannot. Assert it, it's what I should say, assert it, unassertable or indisputable is the better word. So if D is a true false formula, then D is minus of D is a tautology. So D implies minus of D, means truth and false statement are contained in one. So truth is great truth is one whose opposite is also great truth. Truth and falsehood are contained in one statement. So that's a tautology in that sense. So in the same sense, we have a synthetic formula in which intermediate and F, that was asymmetric, asynthetic, where intermediate and false in truth table, or intermediate and truth in that truth table. So it's a complex in that sense, complex synthetic statement, which is also called asymmetric synthetic statement, where intermediate and false and intermediate and a truth as a combination can be seen. Now we come to the complementarity statement, which will start our beginning of how our purpose is to see uh, uh, so complementary statement is in that sense A can be written as B, or this is known as uh, negation, cyclically negation, and this is negation can be written as, this can be written as B, or B can be written as this B can be written as, so it's, so you have changed A to B and B to A. Yes, yes. Now, the thing is that so we are going to see relation of complementarity, relation of complementarity. As complementarity, we also said in that sense, the measurement of one variable at the expense of another. Less accurate one variable becomes, the more accurate becomes the other. So the measurement one it happens at the expense. The qualitative or the quantitative, the more you make one measurement accurate, it comes at the expense of the other becomes less accurate. So in that sense, you can say complementarity. So complementarity can be seen as truth value of, as opposing truth value of indeterminacy of two values of truth and two values of truth and falsehood, which is a unique feature of three value logic. So now, so among all the combinations and statements, so that is in the general substrate, we are making these truth with false, false with truth, truth with intermediate and false, truth with intermediate and true. So these are all combinations in three valued logic, and the table we can construct. So which of them, the three valued logic helps us in articulating this relation of complementarity, where we have opposing the truth value of indeterminacy. So you cannot, the thing is not totally indeterminate, but you can have two values of truth and falsehood. Means one of the variables may be more accurate, the other becomes less accurate. This becomes accurate, this becomes less accurate. So less accurate one you can say as falsehood. Truth may be more the variable which we are more interested, which becomes more pronounced once we concentrate on this and becomes less pronounced. You can say falsehood in that sense. So you can say three-valued logic. So indeterminacy, according to this interpretation, can somehow be put into background while focusing on this thing. This thing rehabilitates. So now, so it can be seen as a logical operation between A and B. So rule of complementarity of quantum mechanics can now be stated in this. If U and V are non-commutative entities such that U implies negation of V, this means double negation of V. So U implies negation of V. So it means double negation. So we'll come back to V. Or V implies negation of V is double negation of U. So it's there are three variables U, V. This implies this is V. So if there are U, V, U, and so this means this is one variable, the other is the opposite of this variable, but the third variable is the double of this thing as an operation, cyclic double negation of this will give this thing. The same way you can see it this way. So the two-value logic can be written as A implies negation of B. So if U is true, V is false. So in the same sense, if V is true, U is false. If U is true, V is false, so on and so forth. If U is true or false, V is indeterminate. So this statement can be extended to propositional functions. Propositional functions. So now we have come to something called functor as a statement. So functor as a statement we have used. The law of complementarity can be exposed to propositional function. Our statement U can be written as V of L E1 T is equal to U. The value of entity E1 at a time, E1 at a time is U. The symbol V, this is known as functor, or value of this will similarly be applied to other entities. So you can have, so law of complementarity can be explained. You can have U, V, T, V of L into E1T is equal to U. So V of VL E2T is equal to U. So this is the double negation. V of E1, E2, T is equal to V. So the relation of complementarity may not be a thing to two entities only. It may extend for more than two entities. For example, three components of angular momentum may be non-commutative. So each is complementary to each other. In order to express So if there are three entities, U, V, and W, so V implies negation of V. So it's double negation of V. So in the same way, we have the way we have done it here. V of U, it's double negation of these, or W implies negation of it. This implies double negation of this in that sense. The relations 33 and 38. This is 38 and 33 is this one. This one, 33. So this relation and this relation means what? Means if one of the three statements, if one of three statements is true or false, other is indeterminate. If one of the statements is true or false, the other is indeterminate. So you can have this thing. So you can say in quantum mechanics, more or less, it's not necessarily three valued statements. So it's the more or less a two valued statement in presence of the third valued thing. You have, for example, the three valued logic in quantum mechanics can be seen as three valued logic. Can be seen as, it will lead us. So you have two false statements. Those complementary statements can be seen which in the background of this something called indeterminate. And we can also include probability statements here also. Only when we take exact numerical values, then we can have three valued statements. Otherwise, two valued statements in the background of the third statement, you can just formulate a quantum mechanical statement. Maybe in the next class we'll see, that will make us more clear how suppression of causal anomalies which were there, while we invoked this three valued logic, how it helps us in suppressing causal anomalies, at least when we logicize the statements of quantum mechanics. Even though those statements, their validity can be had from empirical data, you can see it that way. But the way we conceptually theorize this entire thing, so we'll see how three value logic may be more helpful in trying to do away with those causal anomalies. Stop.